Hi everyone, welcome back to OILS 513. This is the third learning module in our course, and this week we'll be discussing the information lifecycle, which is a grand unifying theory within the field of information science. Now, the information lifecycle is a conceptual framework that we use to identify and describe each major stage of life that an information object moves through during its useful period of existence within an organization. Now, an important concept in the life cycle theory is that the value that we assign to information objects changes radically over the course of that piece of information's lifespan. Typically, information has a very high initial value to it that tapers off to almost nothing by the end of its life. The life cycle concept also implies that there are discernible stages of change within the existence of any piece of information. So there's a point of creation, there's a point where it's distributed, there's a point where it's actively used, where it might be modified, then where it's saved or it's discarded. Now, you'll hear another similar term called the Information Lifecycle Management, or ILM, and that's used by the technology industries. And really there's a difference between information lifecycle theory that we're talking about now and information lifecycle management. Lifecycle management, or ILM, is typically used by software companies to show how their software or hardware can be implemented in an organization to solve a particular information need. So how does company X's software product or hardware system or data storage system, how does it solve one of the major stages of the information lifecycle within a particular information producing organization? Now, in terms of information lifecycle theory, what we're talking about is a more general academic concept of understanding how information is produced and flows through an organization and how its usefulness changes over time, but it's not necessarily tied to a particular technology solution. So lifecycle theory is a general description of how information lives and dies. Lifecycle management is the technology application of lifecycle theory. Now, that being said, just a little tiny bit of history. Lifecycle concept was originally developed by IBM in the 1950s. And during that era of mainframe computing, it was really intended to show how a large company or organization, say like an insurance company that needs a very large scale mainframe type of computing system back then, how IBM would design and implement that mainframe system to meet all of that insurance company's needs. During the 70s and the 80s, when smaller computers, in terms of hardware, became available and software became more important than hardware for a computing system, the emphasis on the lifecycle model shifted to a software development orientation. So today, while you will see a lot of different variations on this term, but you'll see frequently the idea of the software development lifecycle, SDLC, that's used by many companies to describe how they design and produce software products. The other area of the commercial world that influenced information lifecycle theory was in the area of product development. And most notably, the automotive industry in the 1980s really defined what is called product lifecycle management, or a unified system, a unified worldview of how products are designed, manufactured, and then sold to the public, and then they go under review and they get redesigned and a new and better product is sold. The automotive industry systematized their view of how they develop products to increase their efficiency as companies. This view of information as a product sort of really has infiltrated the idea in terms of academic research of the information lifecycle theory, as many companies in this day and age do produce information as a product. So really, in terms of history, there are two parents to contemporary information lifecycle theory. One is from the product development side in large-scale industry, and the other is from the systems development side in the technology industries. Here are some of the characteristics of an information lifecycle that we can use to identify how the lifecycle operates. So it is, of course, a conceptual framework. It abstracts how information is produced and flows through an organization. It's also meant to be descriptive. It means to fully describe each stage of life of an information object, and we'll find later in the lecture, that's one of its more valuable features when we apply the life cycle model to an organization, is its descriptive power that helps us understand how information is produced and used. It's of course modular, meaning each stage in the life cycle can be readily identified as a separate unit. Scalability is important. The information lifecycle model can be used to describe how one person in an office works, or how a department operates, or how a whole organization operates in terms of how they produce and use and distribute and save the information that they find valuable. And then it can be adaptable. It can be adapted to many different perspectives, as we'll see in a slide that's coming up shortly. There's many different uses for the life cycle model. As I mentioned, the idea of value as it is assigned to information is very important to the life cycle theory. Now, within any organization, people assign a particular value to an information object, and that value changes over time. The type of value that we assign to objects really depends on the type of organization and the type of information. So, for example, in a pharmaceutical company where its raw research data is extremely financially important to the success of the company, we call that, type of financial value. We find in other types of large-scale organizations, like governmental organizations, that information has more of an operational or a problem-solving or a task-oriented value. Information helps organizations get their mission accomplished. It helps them get things done. And then in other types of organizations, schools, colleges, museums, archives, libraries, historical societies, information has a value in and of itself that doesn't necessarily have a financial value, although a lot of historical and cultural information does have a financial value, but it doesn't necessarily have to have that. There's a certain financial value to educational information, but primarily educational information has its intrinsic value. It's valuable in and of itself without any other impeding features. As I mentioned, value of information changes throughout its lifespan, and that's really where the life cycle model has its great utility, is charting how that value changes. So typically we find that information that has just been created has a high perceived value, and that value drops off almost immediately over time as the information becomes obsolete. And unless that information is refreshed or updated, the information will rapidly move into a period where it's either going to become disused or discarded if it's not refreshed in terms of its value. The information life cycle of an organization is actually a whole series of stacked or layered life cycle models, and each life cycle model has a different perspective or a different function within the organization. So it's important when you get to the assignment part of this learning module that you think in terms of creating your own information lifecycle models that are multifaceted and that describe all of the different issues in terms of how information is created and used and stored within your own organizations. So, for example, one type of information lifecycle could be a policy life cycle where we're concerned with the security of the information. So what stages does an information object have to go through in terms of its accessibility to people who want to use the information within an organization? Now, an organization like the Central Intelligence Agency has a very sophisticated policy information lifecycle, and they have many layers of types of access controls on the information. Policy can also refer to how an organization stores information after it has lost its initial value. So in many cases, there are legal requirements, especially here in the United States, that organizations need to adhere to in terms of record keeping for both private companies and government organizations. So these organizations have to create records management departments, and they have to have a lot of concern about how long company records and information objects are being retained. Another type of life cycle deals with the format that the information is produced and used in. This can be both physical and digital in nature, but for example, a company that publishes technical reports probably uses word processing software like Microsoft Word to create their documents, and then they have to reformat them into, say, PDFs or ebook formats for publishing and distribution of their information. So how a piece of information is formatted electronically or physically through its lifespan is a format type of life cycle. And of course, as we just talked about a moment ago, technology-based systems that support information work within an organization have their own individual life cycles dealing with how information moves through, say, a large information processing system, or how information is stored on various hardware devices throughout an organization during its lifespan. So you can see that there isn't just one consideration in developing an information lifecycle. We have to consider all the different components that are necessary to support the creation and use of information in an organization. And each one of these different components has its own unique life cycle design. Now, this is a very basic, probably the most minimalistic model of what an information life cycle looks like. And this was designed by the Joint Information Systems Committee, which is a government agency in Great Britain. And really in Western Europe and the United Kingdom, those countries in the last 10 years or so have done quite a bit on their own national bases for developing coherent information standards that are used throughout their individual countries. JISC is probably one of the best examples of a really stellar information standards organization, and you're actually going to be reading their introductory document to information life cycles during the assignment part of this learning module. But as a minimum, the JISC has defined these 4 steps as being the most foundational steps in an information life cycle. Now, at the end of the lecture, we will look at a number of different other examples of fully developed information life cycles that are used by a variety of different organizations. And you'll see that those life cycles have many more steps and many more layers included in them. But these 4 steps are a great place for us to begin our initial analysis of a life cycle model within an organization. The first step, creation. Creation doesn't simply deal with how an information object like an email is created, mainly by typing on a keyboard, but what are the processes that go into the creation of that information? Is it through research? Is it through organizational activities? Is it through a workflow process? How exactly is an information object like an email or an internal memoranda or a report created within an organization? So this creation phase can be broken into many different other subphases, including sort of like research, investigation, reaction to a problem, etc. Active use assumes that the information that was created in the previous stage has been formatted and distributed to an audience of users who will find it valuable. So there's a lot that's implied in the shifting from creation to active use. And here are some of the issues that need to be dealt with during an information object's active use. Some of those involve who has access to the information, who's allowed to see and use the information. Others involve who has the authority to modify the information, And then finally, who has the authority to say that the information is no longer it's in its most valuable state or most current state? Who can say that the information is now outdated or obsolete? Those are some of the considerations that all information is subject to during its active use phase. And when information starts aging out, starts becoming obsolete, there are two things that happen to it. If the information is important for ongoing use, information that becomes obsolete needs to be refreshed or updated so that it maintains its level of activity and active value within an organization. However, most information objects tend to start to age out very quickly. And in the little graph here, this graph is taken from the field of bibliometrics, which is a subfield of information science. And bibliometrics studies how scholarly information is used after it's published. And there's sort of a universal law here, which involves this long tail on the graph, that it has been found that scholarly articles in academic journals tend to be very highly read and disseminated immediately after they're published, but then they tend not to be reused later on. And so most academic articles, to the chagrin of their authors, immediately move into the semi-active use phase where they really don't have that much value anymore after their initial publication. We find that in most types of information that's produced by any type of organization, that information objects have a very high active value and active use when they're first created, and then they almost immediately move into a semi-active use phase. Another example might be the syllabus for this course. I'm sure that when you all started the course in the first week, you read the syllabus. It had a high active use at that point, and you would assign it at that point a high value. But probably now, by the third week of the course, the syllabus is probably losing its value for you. As you've disseminated, you've already absorbed the information that's in it, and unless you need to go back to refer to it, it's probably going to diminish in use very rapidly over the next couple of weeks. Another good example of how information objects move into active use is semi-active use is in the area of websites. We all find that if you're looking for a particular piece of information on the web, you're always looking for the website that has the most current information. And that in websites, you find that there are still live, but it's obvious from the last updated tags on the articles on the websites that it's been a while since anybody has refreshed the information on that site. You'll always go return to the websites that are very actively updated and probably not return to the ones that aren't updated very often. The final outcome stage is where we have to decide whether information needs to be stored, or it needs to be destroyed, or it needs to be transformed into some other kind of information. Those are really the three options. when information stops being used actively, an organization has to determine, maybe as a matter of policy, that it needs to be retained for a period, and retained in case of legal issues or because of requirements for ongoing customer access to that information. Most organizations will attempt to simply discard information that it no longer finds useful, but there are a number of barriers, the one being legal requirements. Another is that a lot of organizations find that there is some historical value in keeping information around. But the final outcome stage is where this decision is made to either take the information objects out of the current life cycle, in which if they're going to be retained long term, they actually enter another long-term storage information life cycle, and they become transformed from being the information objects in the current life cycle to being members of another life cycle. Or the information can be completely deprecated from the organization, deleted as having no value in terms of retention, or it can be recycled back into the current or into another life cycle, where it takes on another purpose in life and has another life cycle that it becomes a member of. Now here, for example, since I mentioned records retention, this life cycle model is a very basic one that was created by the Association of Record Managers, or ARMA, to show how information objects that belong to a large organization that aren't deemed useful to the main life cycle model of that organization are transferred into a records management life cycle, where the records are created or where they enter into the records management life cycle, and then they are maintained for however long the company's policies require, and then they're disposed of in one form or another. This is a more fully developed records management model that shows sort of both the core information life cycle in a large organization and adds towards the end here, maintenance, protection, and disposition, the records management functions. And you can see between the two that there are added steps in the life cycle process, and that in any life cycle model, there's more than just the 4 basic stages that are outlined in the JISC documentation that you're going to be reading. Now, sort of what good is the information lifecycle model for us as members of our own work and school organizations? What can we use that information lifecycle model for? And we find that there's a number of really good reasons within an organization to use the life cycle model to both identify how information is used within the organization and also how to plan for new services or improve on existing workflow processes. The life cycle model is very good for documenting how information flows through an organization. And you can see this list of examples are really good reasons for any organization to adopt an information lifecycle view of how it produces, uses, and saves and discards the information that makes the organization run. Sort of finish up, let's look at some examples of lifecycle models in other types of organizations. And these vary a great deal, and some of them are not pure information lifecycle models. But you can begin by looking at these to see how organizations adapt that simple four-stage JISC model to their actual organizational needs. So this is one of my favorite. This is both an information lifecycle model and also a student management model. You can see that they have, whoever has authored this model has intermixed pure information management stages of moving students into a college or university through their academic programs and out to become alumni. But they've mixed sort of student stages of development and information management within the organization, both in one life cycle model. And they've actually done it relatively well here. But this is an excellent example of how academic administrators can utilize the life cycle model for their own purposes. This is a very special purpose life cycle model, which is the development and publication of linked open data, which the linked data movement is one where we're trying to develop what is called the semantic web, or to create intelligent links between web resources that are online. And it involves a complex stage of creating additional metadata for links from one web page to another online resource that it references. Here you can see that the life cycle is not only divided into phases, but its author has identified individual information workers who participate in each phase and identified which of those workers are active in each stage of the information development and distribution of these linked data resources. And of course, the military has a very sophisticated information management protocols, procedures, and standards of its own that we rarely get to see in civilian life. But this is called a course of action life cycle, where a mission problem, a military mission problem, is being identified, and courses of action are being developed by both the planners at a high-level military unit level and also the commanders on the ground. So you can see that there are many different contexts where the information life cycle is of value to large organizations. Finally, this was actually developed by the Microsoft Research Division that includes the stages of how scholarly articles are produced and published and disseminated. It also includes a secondary layer where some technology components for the life cycle have been included in each major stage of the life cycle model. So you can see in the authoring stage that they are proposing the use of different add-ins for Microsoft Office software and different technology solutions for publication, storage, archiving, and research and analysis. And finally here, we are going to have a whole module talking about the academic research data lifecycle. And for those of you who are engaged in doing active research, this will be very valuable to you, as this model not only reflects the conceptual stages of how research data is collected and analyzed for a particular research project, but it also adheres to the federal standards for data management, and from planning through reporting, that all researchers who receive federal funding are required to adhere to. So while this plan, this life cycle, is really oriented towards low-level research data collection and processing and analysis, you'll see when we get to the research lifecycle module that there are a lot of different contextual layers to each one of these stages, and that researchers nowadays, because of government requirements, have to take into account a lot more than simple research data collection. There's a lot more documentation and reporting requirements for researchers who receive federal funding these days than ever before.